Hello, this is Mike with another video in the Calculus in a Nutshell series. This video is an attempt to summarize or give you a preview of Module 4, which focuses on applications of derivatives. So as usual in these kinds of videos, my suggestion to you is to consider watching this before you begin Module 4, in order to give you an overview of what to expect in the unit, but also consider watching it at the end when you've finished the module and use it to help you kind of summarize the big ideas in the unit. So let's talk about what you're likely to see in Module 4, Applications of Derivatives. So remember where we are in the course as a whole. Calculus is about three primary things: limits, derivatives, and integrals, and we are in Module 4 related to derivatives. Module 3 was about introducing the main idea about what derivatives are and some important formulas for determining derivatives, otherwise known as differentiation. And here in Module 4, we're going to be applying those basic concepts that you learned in Module 3 to various sets of circumstances. So you'll want to keep in mind that derivatives are rates of change, and knowing how a function changes, in other words, its derivative, that can tell us a lot about the function itself. So we could possibly learn more about how other quantities that are related to it will change, and that's the subject of related rates. And because related rates are a particularly challenging topic in Calc 1 traditionally, I've created another set of slides and a video to go with those slides that I hope will help you make better sense of that topic. Also, if you zoom in on the graph of a function and its tangent line, remember the slope of the tangent line is what the derivative is. And so if you were to draw a function and its tangent line, and you zoom way in on that spot where the line is tangent, then the tangent line is going to look a lot like the function itself when we're close to that target value. And so what that allows us to do is find approximations for complicated functions just using a formula like y equals mx plus b. So that's something we're going to talk about, or you're going to study through this unit, through this module. We can also know whether a function is increasing or decreasing. Think about this. This is a really simple thing if you think about what derivatives are. If you find that the slope of a function is positive, then that tells you that it's going up from left to right, and so thus it is increasing. It's getting larger as the horizontal independent variable is also getting larger. If the function is decreasing, then it should have a negative slope, which means that the derivative should be negative. So just knowing whether the derivative is positive or negative tells us something about the function. And we can learn about how the graph is sort of curved, like what's the nature of its curving using second derivatives. So that's something called concavity. And that's something that will be something that you study in Unit 4. Also, if we know whether a function is increasing or decreasing and where it is increasing and decreasing, and we also know the nature of that change, in other words, whether it's sort of opening downward or upward, those things can tell us about where the maximum and minimum values of the function are. And that's an idea called optimization. So we can find either the highest value or the lowest value, and that can be really valuable in many different kinds of applications. We might want to minimize the cost of a particular technique for producing an object of some kind. Or we might want to maximize profit. So optimization is something that we can learn about there. And we can also estimate solutions to challenging equations. So derivatives are able to help us find x-intercepts, and you may recall from algebra that x-intercepts are one way for solving equations. And so it's a method that Isaac Newton came up with and made famous, and so that will be a topic that you can study in this module as well. So let's just kind of dive in a little bit more into detail about what the various sections are going to do in Module 4. So section 4.1 is that idea about related rates, where one quantity changing causes another quantity to change. And as I mentioned before, that can be a traditionally challenging topic for folks in Calc 1, and so I've created another set of slides and video to go with it that I hope will be helpful there. Section 4.2 is about linear approximations. So an example of that might be it's difficult without a calculator, or it would be tedious to calculate 4.01 to the third power, for example. Of course, a calculator makes that easy, but we can also use calculus to give us an approximation or an estimation of that value just using a simple linear equation. That's what section 4.2 is about. 4.3 is about finding maxima and minima, the highest and the lowest values on a function. And that's going to come from what we know about the increasing and decreasing nature of functions. Section 4.4 is about the mean value theorem, which has some really cool CSI type implications in it. For example, knowing how fast a car has been going, even if you only know how fast it was going at one point prior, and knowing how fast it was going at another point later. But the mean value theorem gives us tools for answering questions related to that kind of thing. Section 4.5 is about something called the derivative tests, and the derivative tests give us information about, again, maxima and minima from section 4.3. And various derivatives also can give us information about concavity. In particular, the second derivative tells us about that. And one more comment about concavity, that the idea there is that because it's the second derivative, we're looking at how the derivative itself is changing. And so the question is really about what is the nature of the increasing or decreasing in the function. Section 4.6 is about limits at infinity and asymptotes, and one thing that this can do is explain some rules that you may remember from a pre-calculus class about how to look at rational functions in particular, but also other things. We live in a wonderful time where technology can tell us a lot about functions. Much of calculus was built and created during a time where we would have to graph functions by hand, where we would have to do calculations like 4.01 to the third power by hand. And calculus made those things a whole lot easier. Now that we have technology that also makes those things easier, section 4.7 is really about trying to merge the ideas together, because we don't necessarily need calculus anymore if we've got technology to help us answer a lot of these questions. But one way of looking at it is that calculus is what undergirds that technology. It's what makes that technology possible. But we can also learn how to use both calculus and technology together to help answer mathematical questions and problems that we have. So that's what section 4.7 is about. Section 4.8 is about optimization, which is directly related to section 4.3, finding maxima and minima, and involves some of the other sections to a lesser extent. And then the last section in this module is about Newton's method, and Newton came up with a way of estimating solutions to equations by using derivatives to find x-intercepts. So just a few things to keep in mind briefly as you're working through Module 4. Always keep the definition of the derivative close in your mind. Derivatives, remember, are rates of change that we can often think of as slopes of function, instantaneous rates of change, or slopes of tangent lines. The rules for differentiation generally are not hard to use, and once you sort of get the hang of using them, and once you remember what they are, which is not easy necessarily, but once you get the hang of those, they're not too bad. But Unit 4, Module 4, can be challenging because applying those rules often requires more careful thought. And then I also want to challenge you at this point to think about how you can use that more careful thought to communicate what you know about different functions or phenomena, and think about how you can explain why certain things work the way they do using calculus. So my advice is to use this unit, use this module to practice ways for going beyond things like I followed the steps and the answer was this. You can go a little bit deeper. You can do better than that. And the tools that you're going to learn about in Module 4 help you do that. So my advice would be to try and go a little bit deeper with your explanations and use the tools that you're developing in Module 4 to help you make arguments, to convince somebody else of a position. And so with that, I will sign off and wish you good luck, and remind you as well that anytime you have questions, you can contact me. Good luck.